Tech Talent, this is Prof G, and I hope you're ready to become magnificent mavens of MVVM because we are about to offer up big learning in the form of an introduction to the model view model design pattern. We'll build on our earlier lectures on structs and classes to show you where each can be used effectively in MVVM. We'll build both as we learn to design more architecturally sound apps. It's our first step on our MVVM journey, but by this lesson's end, you'll be passing data between screens in our ToDo List SwiftUI app. Let's learn big! Now, in the prior lesson, I'd mentioned that we'd begin to show the implications of choosing structs versus classes for different parts of our SwiftUI app. And let's demonstrate one of these areas where we wouldn't want to use a class, but also we'll see problems with using structs. And our solution that we'll get to later in this lesson is going to be that we'll use both a struct and a class to begin to create a more sound app architecture known as MVVM. First, let's create a view in our app that we can use as a demonstration. And after we're done with the demonstration, we can go ahead and delete it. Now I'm going to right-click on Detail View, select New File, and we'll create a new SwiftUI file. It doesn't really matter what we call this because we're going to be deleting it after the demonstration, but I'm going to call mine Struct Class Test View. Now I'm going to create a simple view that has a text view and a text field. And when I enter text in the text field, I want to update the text view. Now we've done things like this a bunch of times in our previous lessons using state variables. Let's see if we can do this with an object we create from a custom class. So just above the struct, I'm going to create a custom class by entering class ToDo, that's with upper camel case because remember structs are types, open and close curlies, and we'll include two properties, var item equals empty string and var completed equals false, although in our demo we won't even be using completed. And now that we have our class, this new type created, let's create a state variable that's an object of this class type. So inside the view struct definition below, we're going to put our state variable where we normally put them. We'll say @state private var ToDo lower camel case equals ToDo upper camel case open and close parens. So this is the initializer for the class, and we don't have to create an initializer because all of our parameters are initialized in the class. Then in the body of this view, I'm going to cut out the text view, create a V stack, and in between the curlies, I'm going to paste the text view back in, and let's modify that string inside the text view so that it says the ToDo item is string interp, and inside the string interp, I'm going to enter ToDo.item. So this refers to the ToDo object's item property. Then down below, let's create a text field so we can get that item property from the user. So we'll enter text field, and let's select the option with title and text. The title string will just be enter ToDo here, and the text is our binding string, so we should use our object in here, $ToDo, referring to .item, which is a string value. I'll set the font to large title, and the text field style to rounded border, and now let's try this out. So in the preview, I'm going to enter learn Swift, and I get nothing updated in the text view. Gack! Why isn't this updating? Well, remember what we learned about classes being reference types? This ToDo item is being updated, but the object is pointing to data in memory. But SwiftUI is looking for the value that's inside ToDo to be updated, and the reference to the data isn't changing. That's what SwiftUI sees. So what we've just demonstrated is that we can't use reference types, we can't use objects created from classes with state variables in SwiftUI. So let's see what would happen if we change the class to a struct. All we need to do is change the keyword class to struct, preview restarts, then let's enter learn Swift, and hey, SwiftUI can see the value in the struct updating, not just the reference. It can respond to that change by forcing a redraw of the user interface, and so that's why we see the text view updating as we type. Nice! All right, so we see some of what we learned in the previous lesson applied in this example, but what we're going to do now is going to be a little bit more complex. Now we're going to introduce a way of organizing our code in our app that's known as MVVM. MVVM stands for Model, View, ViewModel. Now, when we talk about ways to organize code like this, it's sometimes referred to as a design pattern, a sort of repeatable solution, in this case, to the problem of organizing our code. Now, the organizing principles of MVVM isn't just for Swift, it isn't just for iOS. You'll see it in other software engineering contexts as well, and it's not the only way to organize code. Also, even within MVVM, there is no clear way to implement this approach. There's a lot of debate online, but since MVVM is so popular in SwiftUI, this is a good place to start. So I'm going to offer what I hope is a gentle introduction appropriate for our current state in our SwiftUI journey. Now, MVVM is a way to decouple software components so that they each focus on a given use. The model, the M, is the blueprint for how our data in our app is organized. And our views, as we know, represent how the user interface is displayed to the user. Now in SwiftUI, we simply declare how a user interface should look based on the data that it receives. It's a declarative programming approach. And the view model, the last VM in MVVM, actually sits between the model and the view. It acts as a coordinator between how our data should be expressed and how it should be presented in our user interface. Most of the logic in our software code is going to be in the view model. In fact, you'll hear some developers refer to the fact that the view should be dumb. We're going to extract a lot of the code that's in the view and move it to the view model. Now, you'll almost always see that structs are used for models in MVVM. Most of our data blueprints are going to be in structs. Views, we already know, are structs, but since classes are reference types, then they can allow us to manage the so-called source of truth that is our data, so that all of our views point to a single data store rather than passing copies around an app that might otherwise get out of sync. And we'll also use the ViewModel class to contain logic for our data handling, things like creating, reading, updating, and deleting of our data. Now, why bother with all this? Well, one reason is maintenance. Code that is logically grouped is easier to understand and maintain. A change can often be made in an isolated component without requiring changes to all others. You don't need to hunt through your code to find where your program would handle parts that are distinctly broken out into M, V, or VM components. To give you another example, if code is organized in MVVM and you decide to go from, say, saving data to your phone to saving data to the cloud, you should be able to handle all this in the ViewModel components, and in this case, a well-designed app would require almost no changes to the model or view components. Now, code organized in distinct components with defined functionality is also easier to reuse, and reusable components can lead to faster, less error-prone development. An approach like this can also help simultaneous team development. It's easier to assign programmers to focus on a given distinct component, especially if everyone knows how it will behave. For example, how it'll receive and respond to updates, events, requests. And as we'll see in a future set of videos, these components are easier to test. And here I'm specifically talking about a professional method of software testing called unit testing. There's a special way to do this in Xcode, and this goes way beyond simply trying your code to see if it breaks. This can be especially important in SwiftUI, where view models are easier to test, and it's harder to test code that's embedded inside of views. So back in our code, we can delete the file we created when we were demonstrating structs and classes and state. We actually don't need this in our project, so I'm going to click on the file I created. Mine was called struct class test view. I'll press the delete key on the keyboard, and I'll click the move to trash button. And now let's create our model. Remember, this is going to be a blueprint for how data in our app is organized. That's what the model in MVVM stands for. So I'm going to right-click on the To-Do List app file in the Project Navigator, select New File, select Swift File, not SwiftUI view. This is a straight Swift file that we're creating. Click Next, and the custom is to give the file the same name as the component that we're creating inside of this. So we're going to create a struct named To-Do, so that's capital T-O, capital D-O. Press Return, then let's define the struct. So struct to do, upper camel case, open and close curlies, and we actually already created data to hold the components of a to-do item. We have that in our detail view. So let's head over to that file right now, and we're going to highlight and copy these 5 state variables. We'll eventually delete them. Then let's return to our to-do file, and we'll paste them in between the struct's curlies. Now, if we're creating a single struct, we want to make sure that we have these 5 properties in here that will take the place of the 5 variables. So we'll have only one struct that has all these 5 properties of any individual to-do. Now, I'm going to change the first item here from lowercase to-do to lowercase item. That'll be the name of my to-do item. And then in front of all of these 5 properties, I'm going to delete @state private. I don't want that. Private would isolate the property inside the struct so I couldn't see it outside of the struct. We definitely don't want that. We want this to be available to all other files. And every property in here is also initialized. That looks good. Now there's one more thing I want to add to this model, a unique identifier. Let's head over to the to-do list view so I can describe why I want this. Now you see here in the for each statement, up until now we've been adding the \self for this ID parameter. SwiftUI uses this so it can tell apart all of the views that we create inside the for each loop. And in an earlier video, I pointed out that this could be dangerous if you have, say, an array of strings with more than one element that's the same string. So the risk there is that SwiftUI uses an ID that's the same thing for 2 different elements. And I mentioned in the earlier video I was going to show you how to address that. Well, now the time has come. We're going to avoid any problems by adding an ID property to our struct and conforming to something called the Identifiable protocol. And when we do this, we're going to be able to get rid of the ID parameter in the for each statement. So here's how we do that. Let's head back to the to-do struct file. And first we need to conform to the Identifiable protocol. And remember, protocols enforce the rules. The rules here are going to be the rules to be identifiable. So right after the name to-do in the struct definition here, I'll say : identifiable. And this one says we don't conform to the protocol. We need something. So you can click on fix to add the stubs. Stub me, Xcode. And what this does is it says we need a variable named ID. And it says that this is an object identifier. Now we're going to make some changes here, but the real important thing for any struct that conforms to identifiable is to make sure that you've got a property named ID, lowercase letters, in here. Now I think in most cases it's better practice to make the ID a constant. So I'm going to change var to let. let, and I'm also going to set this up so that when an instance of a struct is created, I'll create a special unique identifier and it'll be put inside this constant. And having a constant I think is important here because this should be a unique number that you have forever and it never changes. Sort of like your student ID if you're a university student, or a social security number if you're a US resident, it should never change. Now to actually create the unique ID, I'm going to backspace over object identifier and the colon, and instead I'm going to type equal, and here I'm going to use a built-in Swift capacity to generate a unique value. It's called UUID, all capital letters. That stands for Universally Unique Identifier. It's a common accepted standard to create a unique value. To create one, highlight the option that has the two parens after it. That says essentially go to the UUID factory and create me a new UUID. Press return to accept this, and then after this I'm going to add .uuid string in lowercase, and this will just make sure that the UUID that's generated is a string. Now I probably never need to have it as a string, but I like to have it in here just in case I ever need to take a peek inside of the UUID value, and maybe I want to print it out or take a look at it as part of testing or debugging. So if you ever want to create unique structs, and you almost always want to do that when you set up a model in SwiftUI, conform to the identifiable protocol with :identifiable, and create a property called ID in lowercase letters, and I would suggest using a constant instead of a variable because you don't want that to change, and you can get this generated for you automatically by saying equals UUID parens .uuid string in lowercase letters. Cool! So now we've got a blueprint for our to-do data structure, our model, so let's create the view model. This will actually create and manipulate the data using that model. So let's right-click on To-Do in the Project Navigator. We'll select New File, and this will also be a Swift file, not a SwiftUI view, and we're going to call this To-Do View Model, upper camel case. And as we mentioned, our view models are classes, so inside this we'll say class, again, To-Do View Model, upper camel case, open and close curlies, and we'll eventually add methods in here, but right now we just want to state the data that we want to create and manage. So this is going to be an array of to-do structs. So I'll say var lowercase to-dos plural colon square bracket with to-do in between, and we'll set this equal to empty brackets because initially we don't have any to-dos in our to-do list. Now we want to make this to-dos property visible in SwiftUI, and to have any changes to any to-do trigger an update of the user interface. This would be the equivalent of what a state variable can do in a single view, but we demonstrated early on that state doesn't work with classes, and state also works only with a single view, but we want our to-dos data to be available across multiple views because we've got the to-do list view, and then we've got another screen with detail view, but we can make this happen with a few simple steps. First, we're going to add an @published property wrapper in front of the to-dos variable. Published says, hey, I know this is a class, but because it says published in here, anything that changes inside of this value is going to be announced, and SwiftUI can use this to trigger a redraw the user interface. So in that way, it works kind of like state, but it works on objects created from classes. Now to get published to work, we need to conform the class to what's called the ObservableObject protocol. And the way we conform to protocols, we know how to do this. We just put colon after the type name, so after to-dos view model, colon, and then we're going to add the word ObservableObject, that's upper camel case with 2 O's. Now you want to be careful when you're selecting in code completion because there's also an observed object. You want observable object here. We don't need to do anything additional to conform to ObservableObject, but this says that this object of type to-dos view model has one or more published properties that will announce their changes. So ObservableObject and the publisher property wrapper work together. ObservableObject is for the class, published is for the properties in the class. Now there are a bunch of ways we can take advantage of ObservableObject in our SwiftUI code. We could create a new object using what's called StateObject and then pass that object around to other views where it would be an observed object, but the technique that we're going to use here I think is even better for our use. We're going to create a single new object. We're going to set it to what's called an EnvironmentObject, and I know there are lots of different names here, so try to pay attention to what those names are and what they do. But the EnvironmentObject is going to make this object available to all of our views. And the advantage here is if we make changes in one view, say our detail view, those changes will immediately be available in all views. So say back in our to-do list view. So here's how we do that. So first, let's head over to the very first file used in our app. That's the file that ends in app, and in this project, it's the file to-do list app, so find that in the Project Navigator and click it. Now, we haven't looked at this file since our very first lecture in our first project, but if you look at this, it creates something called a window group, meaning it creates the first window or first screen in our app, and it uses the to-do list view to do that. That's that first file where we've really done any coding. That's the one with our for each statement in it. Now in this app file, we're going to add code to create an object of type ToDo List ViewModel. And when we create it here and set it up as an environment object, it's going to be available throughout our app. Here's how we do it. First, to create an instance of any observed object, and we just created our observed object, we do this only once. We're going to create that value using a property wrapper at StateObject. So add that, and then after this, I'm going to say var ToDo's VM in lower camel case. That's what I'm going to call this object, and I'll set this equal to the class ToDo's ViewModel upper camel case because that's the class. And since we want to create this, we'll put open and close parens after this, and we didn't need to create any initializer with parameters to pass in, so we just use empty parens. So this is going to create a new object named ToDo's VM from the ToDo's ViewModel class. So the state object is used only once to create a new observable object. Yes, I know it's another term, but know what it does. State object creates the first instance of observable object. Use that only once. And now that we've got this object created, I'm going to make it available to all the views that come after this. And I do this by adding a modifier under the ToDo List view. So that's the first view that launches in our app. And I'll say .EnvironmentObject. This is lower camel case. And in between the parens, I'm going to pass in ToDo's VM. That's the state object that we just created up here. So again, 2 steps. First, create a variable that has a state object property wrapper out front. This should be an object of a class that conforms to ObservableObject. Then we want to add the .EnvironmentObject modifier underneath the first view in the Windows group, and we want to pass in the name of the state object that we just created. This is going to set up this object so that it's a single source of truth that we can access across our views, starting with the ToDo List view and any views that are created by the ToDo List view. Cool. So let's see how we can access this environment object on other views. And why don't we start with the detail view first, and then we'll work our way back to the ToDo's List view. So click Detail View in the Project Navigator, and let's highlight all of the state variables plus this past value string. We don't need any of these anymore, so delete them. And then to access the environment object that we just created, just use the @EnvironmentObject property wrapper. And no, this is different from the environment property wrapper above, which was used to create the dismiss button. Don't confuse them. And then we'll create a variable declaring this with var ToDo's VM, lower camel case. That's the same name that we created on the prior screen, followed by colon, and its type ToDo's ViewModel. So notice we don't initialize this to anything, but what SwiftUI knows is to grab any data out of the environment object that we'd previously created. This is going to be shared across all our views. And that's it. We now have access to this variable and all of its data, and if we make any changes to it, we'll make those changes available to other parts of the app. Now remember, this ToDo's VM is going to have access to our array of to-dos, and we'll eventually have methods in here, some logic to handle how we add data, update data, delete data, etc. But we want one more variable on this page too. It's going to be an individual to-do item on this page. It's going to be passed over from our to-do list view, and it's either going to be the item that's passed over from the navigation link when we click on one of those navigation links in the for each statement, or it's going to be a new to-do item that comes over from the sheet when we click on the plus button. So to create an item to hold a single to-do, we're going to create a new state variable with @state. We'll follow this with var, not private var, since we want to access it from the previous screen. We'll call this ToDo lower camel case, and we'll say colon, and this is going to be of type ToDo the struct. Now it's okay this is a state variable because we're only going to be using it on this screen, and it's okay it's a struct because, again, it's only being used on this screen. It's not going to be passed around. We've also specifically not initialized this because it's going to receive a value from our previous screen, either from the sheet or from the navigation link. Now we're going to update this on this screen, and when we press the save button, we're going to take what's inside this state variable, and we're going to use that to update the to-dos array that's inside of the ToDo's VM. Now these spots where Xcode is finding errors are where our old state variables were. And now we can use that single state variable that we just created, which is of type ToDo, and refer to any of the 5 property values inside of it. We don't have an error in ToDo in the text field, but we do want to change that because now it's ToDo, which is our struct, and we want to refer to ToDo.item in here. And we can paste ToDo dot in front of all of the other variables since we named the properties of the ToDo struct the same as the old state variable names. So reminder is on becomes ToDo dot reminder is on, due date is ToDo dot due date. Also make sure that you add ToDo dot in front of the reminder is on in the disabled modifier. The notes text field should be ToDo dot notes. Toggle should be to-do.isCompleted, and the only error that we have left is the preview provider, and those are always pesky. Now we no longer have this past value in here, so let's backspace over that, and when we retype detailed view, we have this option here where we can pass in a to-do value, so press return on that, and we'll pass in simply to-do, capital T, capital D, with empty parens. So this will create a new to-do object that the preview provider can use. It silences that error, but there's one more thing we want to do in the preview provider, and that's add an environment object. And we'll use the same notation we used on the very first page. Again, the notation is a little bit weird here with the preview providers, but just follow these steps. Underneath where we create the new detail view in the preview provider, we'll just say .environmentObject, and we'll pass in to-do ViewModel with empty parens. Now we still got some errors in here. I think we can find them all in the to-do list view, so let's head over to that file. Now we no longer want these placeholder values in the array of strings. We're going to have an array inside of our to-dos VM object. So why don't we highlight and delete the old to-dos array of string, and we want to add our environment value to this view as well. We do that the same way we did it with the detail view. So if you want, you can head over to the detail view, highlight and copy the environment object line, head back to the to-do list view, and paste this in just under the struct definition. And now we have access to our array of to-do items. It's inside this environment object, and it'll be available in both of our views. Now, one thing that we don't have is any placeholder data in this. We just deleted that string of data. So let me show you how we can create some temporary data that we can add to our to-do list VM model. We'll do that in the to-do list ViewModel class. In here, we're going to create an init function, an initializer, to create a bunch of elements in our to-dos array. And since it's the initializer, it's going to do this when an object of this class is first created. We do that in the to-do list app file in our StateObject. Now, we're going to eventually delete the data that we add in here. We'll eventually actually load data that we save in the app, but for now, let's just create the initializer function with init, open and close parens, open and close curlies. I'll add a comment here that says temp data here will eventually load in save data, and we add data by saying todos.append. Remember, todos is our published variable up here, and in between parens we'll say capital to-do, and if you start to type the word item in here, you'll see the item parameter turns bold as well, so press return. All we'll add in here is the item. You can add whatever string you want. I'm going to say learn Swift, then I'll copy the append statement, paste it down below. I'll add this to-do item as build apps, and I'll paste in one more, and this one will be change the world. Now let's head back to the to-do list view and see if we can get this to show up. First, we can change this for each statement by highlighting starting at the comma after to-dos and deleting the ID self. We don't need that anymore because to-dos conforms to identifiable. Nice. Now what I want to pass in here to the for each though is not to-dos anymore. It's going to be to-dos VM.todos. Now this to-do variable here refers to every iteration through the to-dos array that's inside of the to-dos VM object. It's totally okay to continue to call this to-do, so I'm going to keep that here. Now I am going to update the label, the text field in here. It shouldn't say to-do, it should now say to-do.item. And we no longer access the detail view with past value, so let's backspace over that. But as I retype detail view, I see I've got an option in here where I can pass in a to-do, so select that and press return. Any value we pass in here is going to be used as the state struct value on our detail view, and the to-do that we want to pass in here is just going to be to-do. That's the value that we're iterating through each time we go through this for each. So that takes care of our for each and our navigation link, but now we got to update our sheet. Same thing, let's get rid of the past value that we have in here, start to retype detail view, select the option with to-do, and in here, we're creating a new to-do. We're not passing in an existing to-do, so we're going to enter capital to-do, open and close parens. So this is going to load up the to-do state variable in the detail view with a new to-do that uses all of the to-do default values. That'll initialize a brand new empty to-do, and that's what we'll see when we press the plus button to add a new to-do. And ugh, I get this crash in Xcode. This happens quite a bit. I'm just going to say okay and ignore this. It might have something to do with the preview provider. So down here in the preview provider, after it calls to-do list view, I'm going to once again add the .environmentObject modifier, once again passing in to-do list view model open and close parens. And great googly moogly, will you look at that? We've got this showing up in the preview provider. Let's click one of these guys. Learn Swift passes over the Learn Swift value. Nice. Cancel. Click plus. We got a new value in here. Looking good. Cancel. What if we want to add a new value in here? Click plus again. How about please save me? No, the save doesn't work. We've got to update our save value, and we're going to do that inside of the detail view. Let's head there now. Now down here in the button code, I've got a to-do comment. I'm going to put a new comment in here that describes what I want to do. If new, meaning if we've got a new to-do item in here, append to to-dos VM.todos, else update the to-do that was passed in from our list, So how do we know that we have a new to-do item? Well, there are a few ways we can do this, but I think the easiest way at this stage of our SwiftUI skill set is just to create a variable that says if we're entering a new to-do. So I'm going to head up to the top of the detail view, and we're going to create a new variable var, call this new to-do, and we're going to set this equal to false. So it's got the default value in here for false. In most cases, we'll say, hey, we're not creating a new to-do. So that'll make it false by default. But if we want to, when we call detail view, we can pass in the new to-do value, and we can set it to true. If we don't do that, it'll be false. So why don't we do that when we create our new to-do and we click on the plus value and present the sheet. Let's see how to do this. We'll head back to the to-do list view, and when we call the detail view inside the sheet is presented down here, let's backspace over the last part of the detail view call. We'll retype it, and as we start to type, I'm going to type detail view, but also I'll type in to do. We see that highlights the to do parameter and n, and that highlights the new to do parameter. So both those parameters are highlighted. Those will both be entered when we press return. So do that. Now I'm going to continue to pass in capital to do, open and close curlies for my to do parameter in here. That's going to create the new to do. But if I tab over for the new to do parameter, I want to pass in true. So this is going to say, hey, I'm creating a new to do. And if this is the case, then I want to append that new to do to my current list of to-dos that's inside of the to-dos VM object. So let's head back to the detail view. We'll head back down to our button action for the save button. And I'm going to say if new to do, open and close curly. Remember, new to do is a bool value. So if it's true, we'll say to-dos VM dot to-dos dot append, passing in to do, lower camel case. Remember, that's the state variable that's local just to the detail view. That's going to update our environment object. And there's one more thing we need to do. It's really easy to forget this. We need to dismiss after we've updated that value. That's going to let us leave the detail view and get back to the to-do list view. So after the append line in here, we want to say dismiss in lowercase letters with open and close parens, just like we did in the cancel, although this time we've updated our value before we cancel. Let's head back to to-do list view and try this out in the live preview. Click plus. For this to-do, why don't we say take a vacation? And you can turn on set reminder. And why don't I do that 60 days from now? Hopefully I'll have most of this course done by then. Then moment of truth, click on save. And Swifty surprise, will you look at that? Our take a vacation reminder is at the end of our list of to-dos. Nice. We've updated this. We've passed the value into our environment object, and it's available in our to-dos list view. Now, if we try to update any of these values, let's click on take a vacation again. We see that this is passed over to the detail view. Nice. At the end of our to-do line, why don't we add in, comma, my friend, then click on save, and nothing happens. How come? Well, when we clicked on the navigation link in our to-do list view, we did not pass in the new to-do value as true. So it used the default value as false. So when we pressed on the save button, the button action never executed any code. It only executes code if the new to-do is true. And we never hit the dismiss line either. Swift, or why don't we handle the update in the next lesson, and we'll also refactor our code into our view model. But as far as big learning goes, this lesson was chock full. We showed why objects from classes and state properties don't work. We introduced MVVM, how it's structured and why it's important. We created a model. We conformed it to the Identifiable protocol, and we learned how to create a unique ID with UUID. We created a view model, an observable object, and a publisher property. We initialized things with StateObject, passed that object in using the EnvironmentObject modifier, loaded the environment object into two views, created dummy data, updated our preview provider, and we learned to add a new to-do and update our view model to reflect that change. We've still got a lot more work to do in our MVVM journey, but these are some strong SwiftUI skills, programmer. You're well on your way to becoming a magnate of MVVM. Continue to hack.